Hey guys, welcome back. My name is Peter, this is TechSavara, and today we're going to explore Metal, Apple's Metal. Okay, Metal, wow. Where do we start? Metal is probably behind 99% of everything that you see on the screen in rendered anyway. For Apple platforms on iOS, on a Mac, on iPad, on everything pretty much. The low-level rendering system that's used to draw things on uh, Apple graphics card is powered by Metal. Now, not only that, Metal is used for other things. It is also used for calculations, and it has its own shader system that you use. The calculations, I guess, are powered by hardware acceleration. So there are essentially three parts to what Metal does. One is it has a render pipeline, which allows you to send things to the graphics card, like commands, and it executes those commands. The other one is it has a shader system, which basically uh, takes a block of data and performs a mathematical calculation on it to then use that to present, I guess, a triangle. So, for instance, a shader would be something that you have a battery, a texture map from, and you use that to get pixels and draw that based on the resulting calculation of where that pixel would draw a particular color. Lighting calculations for shaders also. So the shaders essentially perform calculations that take some source of data and provide a resulting source of data. And generally, that is based on a position in a triangle in a geometric shape. So it comes with an input position and it comes with an output result. So you have color shaders, you have different, gloss, like you use them for color, you use them for lighting, you use them for ray tracing, things like that. So the other one is the calculation system. So Metal comes with a kind of a bulk data set that you can present and perform calculations on. And this is really useful, for instance, when performing transformations. So if you've looked into anything to do with rendering, then you'll know that you have to put things within a certain view, a certain angle view. And what happens is that you'll need to perform a lot of calculations to take what you have, say, in world space, and then convert that to screen space. And you have to perform those calculations a lot. And all three of these can be used for other things, and people can perform, certain calculations to perform, very fast calculations across a large data set for data science. Uh, you can use it possibly also for using that to process data sets, but I think, most of the time it's used for the purposes that they're defined for. And it's generally taken advantage of by developers for games or simulated systems. So it basically sits at the bottom, right? So you have Metal, you have all of these other layers that sit on top, and if you're an old school dev, you might have heard something called OpenGL, and it's essentially their kind of like own form of OpenGL. Now, while looking through all the information about Metal, and there's really not too much about it because most people don't need to use it. But if you're like me and you want to do something cool and make it fast and optimized, then you kind of want to start with Metal. And say, for instance, you want to draw you have a video game engine in mind that does things in a particular way to accelerate for certain specific cases. So you might want to, do high-end 2D top-down rendering. So you optimize your pipeline and your calculations for like a really super crazy, 5 million triangles drawing 2D special effects. It's kind of like that kind of thing. You couldn't do that in Unity. You'll never get the speed. You couldn't do it in pretty much any cross-platform. If you really want to optimize for speed and to make it really, top-notch, then you have to, start at the base. And the reason it's probably called Metal is because you're, talking directly to the hardware, which is the metal. So let's explore what we can find, and I don't know if we will get to it, but maybe we can get something drawing on screen. So let's go, guys, and jump into Metal and explore it from the ground up. This is an introduction, so, let's have a look around and see what we can find to get us started in using metal and how it works. Let's go. All right, guys, let's dive into the world of metal and accelerate our graphics. So the first point of call, the first place I kind of looked was in obviously the metal documentation on Apple's website. Now, here's something to think about. All of the documentation and all of the code that's written is only available in Objective-C. I'm sorry, guys. There is no, I could not find a Swift example online. Now, I haven't downloaded any sample apps, and I know that there is a Swift by Tutorials book, and I have that Swift by Tutorials book, but we're not going to go through that. If you do want to get Metal by Tutorials, Codeco, previously known as Ray Wenderlich, has a lot of good books about various topics, probably the best resource out there. So overall for everything. So we're talking about, games development, we're talking about server apps, Android and iOS. So we're talking about native Android and native iOS, so Kotlin, Swift. There's some stuff there about Objective-C, but there is this book here, which is Metal by Tutorials, and I don't think it's necessarily been updated. You can, I have purchased this, and I would love to build my own, stuff with custom renderer. It's definitely something on my to-do list. I've done it as a job previously for various different platforms, not with Metal, but with OpenGL. I've done it when OpenGL was for iOS previously. I built a renderer for video games back in 2010, 11. Before that, custom rendering on various different hardware platforms. Mostly like the low end stuff like Nintendo Game Boy, Nintendo Game Boy Color, Nintendo DS, things along of that ilk. This kind of goes through everything. It tells you, how to, what 3D models are basically, and how to, create models, etc., etc. So it goes from the ground up, so you can understand how models are structured. Really good resource if you're beginning, if you want to know from the ground up how to use Metal, and you don't really know much about the the way the 3D models work, then absolutely, this is a great book. And also, if you just want to know Metal specifically, then you go straight into it, right? So you got, Hello Metal, what are we rendering, right? So this is what is rendering, what are shaders, all that kind of stuff. So one of the things that's good about this book is it's written in Swift, so this is excellent. There is also another good resource, which is Metal Shaders, like Paul Hudson. If you're into iOS development, you know Paul Hudson. Pretty much all of the Swift tutorials out there. Like he's written all these books. Amazing, he does amazing work. Just amazing, how much stuff he's created. Everything from Vapor to Swift UI. Recently, not so much. I think there's just too much for one person to do. Previously, you could kind of have one person do a lot of this, but there's just so much stuff out there now with Swift that I was blown away by the amount of work he's done. So that's another one. Paul Hudson, Metal by Tutorials. Paul Hudson. Make a note of these guys. We also have the WWDC video. These are also excellent introductions. In particular, Metal 3, which is not that old. It's got a lot of new stuff. We've got machine learning acceleration. We've got metal effects upscaling, which basically means that you can take, say, a triangle and scale it up with textures and anti-aliasing and all of that stuff in hardware, right? So you can do something renders to a small space, scale it up, and it'll do it for you. So we've got this. Then you got the Apple website with the documentation. So let's dive in. I think the first thing that I did here was we went straight into the Metal documentation. I wanted to just get started. So what I want to do is, we do a process here, right? So the process is we try to understand how things work by experimenting, and then we'll go in and then develop a structure around what we do. So what I generally do is I have my iPad here, right? So I have my iPad, and uh, what I will do, is I'll write some notes about what I want to create. So in this case, with metal, there are a number of things that we want to do. We want to experiment, learn how it works, and then we want to take those lessons and then start building a structure around it so that we can actually begin implementation. I think, I really think this is worth doing as a separate video. So I'm going to do another video about rendering um, infrastructure because metal is so big. It's such a huge space that we'll do a quick intro here, and then the next video we'll do a further dive with trying to understand how rendering pipelines work and structuring in a system around that. Experimenting drawing a triangle is one thing, but then building a rendering engine is another. So we're not going to go through and build a full rendering engine. I think I'd love to, but we're going to do maybe a couple of videos. One experimenting with just getting set up here, looking at the documentation, and the other one is to look at the structure of a renderer and how that works. So Metal itself runs things like Reality Kit, Scene Kit, Sprite Kit, Core Image. So basically what that means is that if you understand Metal and how it works, you're going to get closer to say for instance the Vision Pro and how that renders. It will be using the same system. It will still be using Metal to do all the rendering. And there's a Metal shading language specification. So we just want to find out, okay, well, how do we draw something on the screen? So, Metal, you can even see here, scientific research apps. So this is a good example of what Metal does, right? So Metal can do games. It can do video processing apps like Final Cut Pro. It can do scientific research apps for analysis and processing large data sets, which I mentioned previously, and fully immersive Vision OS apps. You know, let's uh, let's draw something. Let's try and draw something. We've got using a render pipeline to render primitive. So we can use a metal kit view and render paths to draw the view's contents. We don't want to do that. We want to actually create a rendering system here. So what do we got? We've got some metal sample code library using metal to draw a view's contents. Let's see. Performing calculations, customizing a TensorFlow operation, customizing PyTorch. No, not necessarily. We want to using metal to draw a view's contents, a render pipeline, render primitives. So creating a custom. Okay, here we go. So this will tell us, how to draw a triangle, right? So again, like I said, this is all written in Objective-C, so we don't have anything for us. We want to have a look at, render a simple 2D triangle. Okay, this sample shows how to configure a render pipeline. So again, when you want to do something simple like draw a triangle, same thing as OpenGL, you have to set your infrastructure up, right? And in this case, if you've worked with Apple, you have these things called views, and essentially you would do something in that view. In this case, we have a render pipeline that would render to we would encode commands, send them off to the GPU, and it would draw them. And in this case, we want to figure out how. Okay, we have a render pipeline, and then where would it draw it, right? So we create a render pipeline state object. Okay, so and then we send it command set a viewport. So we tell it what viewport we want, and then we create some vertices. So we create the points that connect the triangle, and then we draw the primitive. So this is kind of like the higher level stuff in that we have a drawing a primitive. We're not actually sending specific commands. Which okay, cool. So I wonder what it does it in. So this wouldn't do it in a metal view, right? This would. Okay, so we have a vertices, vertex pixels, and that I guess it would render it to some kind of. It would render it to some kind of texture, and then what we do with that, I guess we could put it onto our view somewhere. We have creating a custom metal view. All right, so implement a lightweight view for metal rendering that's customized to your needs. So okay, so we have this thing called MTK View, which I mentioned previously, and it's what allows us to represent what we draw onto the phone. So say you have all these triangles that get drawn onto a particular texture or piece of memory, then how does that get pushed up to the screen? So in this case, we create a view that then goes onto the actual layers of our app. We don't actually have direct access to the full screen per se. I think that's done somewhere else. It's a CAD display, that's right. We have a CAD display for the link. So this is really important. It's really important because we can take control of the entire screen here. You don't have direct access to the screen, but you have a CA core CA display link. So AAPL UI view creates a CA display link in the setup CA display link for screen method because you need to know which screen the window is on before creating the display link. Right, so this will tell us the display that it's on. It tells the screen. And we would need to set it up. So again, all in Objective-C. I've worked in Objective-C, so I understand all this stuff. It's not too much of an issue. Let's have a look at CA display link, a timer object that allows your app to synchronize its drawing to the refresh rate of the display. All right. Yeah. So it just basically allows us to call a function when the screen is refreshing. So we don't draw stuff while it's drawing the screen. All right, so what else do we have here? We have CV display link. So we have the metal view, and we have a metal layer, core animation layer that metal can render into, typically displayed on screen, reading pixel data from a drawable texture. So this is what we want really, like when we were talking about rendering the triangles, we have to render it, we have to draw it somewhere. So we don't have, again, we don't have direct access to the screen, but we have something that allows us to synchronize with the screen refresh. So there's a lot to go here. There's a lot. Loading textures, implementing order transparency, encoding indirect command buffer. So, you know, in Metal Bio tutorials, if we go say what are 3D models? We don't need to go through there. We want to look at the vertex function. So we have a shader and we have a transform. So what basically happens is when you render something, you might say specify, the specific coordinates of a triangle. Here is a triangle, right? But then in general, you have that in a space, a 3D space. So you'd have it say in world space. So let's quickly dive in and get one of these examples. Let's just jump into the example of drawing a views content. So essentially what I would do is I would go through each of these samples. Let me download this one. Go through each of these samples and we just explore them, run them, and look at the code. And then after that, I would go in through one of the tutorials. So in this case, we have our, we'll have our using Metal to draw our Metal view content Xcode project right here. There we go. Trust and open. Here we are, our lovely little Xcode view. Now, we have rendering set for tvOS. We don't really need that. Let's do Mac OS, my Mac. Let's just run it. This is what I usually do, just see what happens. We'll just build failed. Doesn't like it for whatever reason. Requires development. Okay, so we'll just select a team. Make sure we have our team here. Let's do auto signing for everything. Oh, this one again. Oh dear. What about my personal team? Surely that one's got it. Yay! Okay, we have that. Just a personal account. I think that's. Let's see what happens. Gonna do it. Run it on my Mac. Okay, great. Excellent. We can run something. Let's see what happens. We have a rendering setup, Metal Kit, and rendering setup. Well, it failed to open data from somewhere, so this sample doesn't work. But let's see. F open failed for data error. No such file directory. Maybe it expects a file to be somewhere. App delegate. So we open it again. See, look, Objective C. We did have a view. We said it is display color, red. No, what would be this? Clear color. MTL clear color depth, red, green, blue. All right, so as soon as the view loads, we have a view here, MTK view, and this is going to, this will set up the view, right? AAPL view controller. Let's have a look on iOS what we have. I think it'll just have actually on Mac OS. Okay, so we have our MetalKit render up view control. This is the container view, and this will be the view controller scene. The object AAPL view controller. AAPL view controller. All right. Well, I mean, we have our renderer. So we have a say that you got an object, right, that does the rendering. That's essentially, we have the view that contains the result of the render, and then the renderer does something. In this case, it probably just draws a rectangle. But what you would have in, say, a more comprehensive system, you'd have like, well, let's have a set of objects that get passed into the renderer. Let's have a transform that transforms these things into screen space, and then pushes through all of the triangles. All the triangles would have references to textures, all that kind of stuff. And it's huge. It's an immense amount of work to get a renderer working, and this is why so many people just resort to cross platform, because it's so much easier just to go, oh, well, here's a cross platform tool. But you just don't get that speed. You don't get that optimization that you would find with a real renderer that you wrote yourself. And the other thing is it's your own IP, and if you wanted to do something fancy, you could always do it, or if you have a team, then you can get someone on your team to do it. It depends what you're going for, right? There might be some case. In most cases, like this is one thing. Before we go, I want to mention something to you. If you really like doing rendering and things like this, you have to understand for video games, the graphics and the technology don't make the game. The game makes the game. And that's what so many people's, in so many cases seem to forget. It's like the story and the game and the interaction with the game is what matters. It's not the tech. You can't make a game great by giving it good graphics if it's just not a good game. But if it's a good game, then adding graphics helps. But it's not the be all and end all. There are a lot of other cool things you can do with Metal for industrial and enterprise applications, especially when you're working with large data sets, which is pretty cool. For me, I just like, I think it'd be nice to do something interesting as an experiment, not necessarily for any commercial purposes. If I wanted to do my own renderer, then I would be locked in with this renderer to the Apple platform, which is kind of fine. But it also means that I can do things with the graphics that you can't do if you use a cross-platform renderer. You can try, but it'll be a headache and it won't be as fast. So on that note, remember, there's a lot to do. There's a lot to figure out with Metal. A lot to do. Let's just change while we're here. We've got that renderer. We don't. It's not doing anything. We have a command buffer. Draw it into MTK view. Current drawable. Get the drawable that we presented. Drawable size will change. Maybe in the documentation, it actually tells us a little bit about drawing the rectangle. Clear the view. That's what it does. The delegate drawing responsibility. So we go to the renderer. We have a render pass script to create a render pass. When you draw the GPU store, so where's the render pass? MTK view drawable size will change. So do we have a render pass? NVM encoder. Was MTK view drawable size will change? Okay. So here when you draw, let's see. Well, okay, so we'll create a render pass, and then what we want to do is yep, and then we have a command encoder. So again, like you have to create a command encoder. So we'll do this here, right? So we have our command encoder, command buffer. Oh, we don't have a command buffer. Where is the command buffer? You can create the render pass by encoding into the command buffer using it. Render command encoder with. So do we have a render? An AAPL. Where would we get the command buffer? Interesting. In this sample, rather than configuring your own render pass scripter, ask MetalView to create one for you. Okay, a render pass descriptor describes a set. Solid color matches the view's clear color. Because the view's render pass descriptor might be null, you should test. Okay, well that makes sense. Render command encoder. Call the command buffer's make method and pass in the render pass descriptor. That's a different function. So the actual thing is here with the descriptor, but where do command buffer? Doesn't really tell us where the command buffer is in here. So the documentation is already sending us down the garden path. So does the descriptor have a command buffer? Well, if it's Objective-C, we have to reference things like this. Let's have a look. So we have our other color attachments, stencil. Okay. Well, we've got this here. Ah, there we go. Is the command queue. There's already one up here. Draw in called whenever the view needs to render a frame. Really? So this is already doing it. This has got our command. Okay, so we have a render pass descriptor. We have a command queue that has a command buffer. And then we have this encoder, and we encode here command end encoding. So obviously we want to encode commands here, encode our buffer commands here. All right. And so let's see what it says. This is render command. Okay. But the actual documentation, it's, yeah. There you go. So that's another thing to kind of present a drawable on screen using Metal Computer Draw. So now we'll go back to the top here and draw using a metal customize render pass. Okay, using a render pipeline. So render encoder, draw primitives. Interesting. So what about if we do something like this, right? Until triangle. It's just kind of like, okay, until type primitive vertex start, vertex count, and well, we need an APL vertex and we need some data. So we could just kind of throw this here, and we'll throw this data here. So we have a data set that we want to draw our triangles with, and struct rasterize data. So we have color, declare the vertex function. So this is in the shader, right? So I think this is like vertex shader. Now, write a vertex function. So we would need to actually write the vertex shader for this. Viewport size buffer. Yeah, okay. So write a fragment function. So yeah, that's right. We would need to write a fragment function, which would render out. Which would execute this command. So basically we would put this command in, and we would give it the function to render fragment here, fragment float, fragment shader, and then yeah, here we go. So we'd pass in the function and the fragment function, and we'd pass in the pipeline here. So that's the pipeline descriptor. Yep, so then we would have the vertex byte. So we basically specify the data set and we specify the command. All right, guys, on that note, I'm going to continue kind of plugging away. I hope you enjoyed this and got something out of it. And I will see you in the next video where we talk a little bit more about the actual structure of renderers and how you can use Metal to actually build out an infrastructure around drawing triangles with different colors. All right, I'll see you in the next one. Bye. Well, so we're moving house, my God. Oh my God. It's not too bad. It's just like there's stuff everywhere. Working on project, one big one that is like Android and iOS. And there's just stuff everywhere in this room. I don't know, that I could show you at some point. Check out my personal channel if you want to see more about that stuff. But yeah, moving house.